Click the bell icon to get latest videos from Ekeeda.
Hello friends, this is the last video from the chapter Wavelets and Multi-Resolution Processing, where for the understanding of digital image processing with this approach we have studied the image pyramids followed by the subband coding along with the knowledge of the Haar transform constituting the base for the wavelet transform into the one dimension, into the two dimension, the efficient transform we have seen, that is fast wavelet transform with respect to the computations. And with this much of knowledge along with the wavelet packets, we are solving the miscellaneous problems. So last problem was based on the understandings of the image pyramids. Now we are going to take one more problem to conclude the chapter with the understandings of fast wavelet transform. So let us begin with the topic. So here we can start with miscellaneous problem number 2. So we want the problem statement here. So problem statement is having the three parts. The part A begins with if the input to the 3 scale FWT, here FWT stands for the fast wavelet transform. So if the input to the 3 scale FWT filter bank is the Haar scaling function. So as we know that the scaling function is always represented with the help of the symbol phi, whereas the wavelet function is represented with the help of the symbol psi. Here phi of n is given with the value 1 with the n ranging from 0 to 7. So here it is mentioned 0, 1, 2, up to 7 we can go. So total 8 values we need to make 1 here and 0 elsewhere. So except the value 0 to 7 we have to put the value 0. The question is, what is the resulting transform with respect to the Haar wavelets? So we shall definitely answer this question. Let us talk about the part B, that is of the miscellaneous problem number 2. Part B starts with what is the transform if the input is the corresponding Haar wavelet function psi of n given by the first 4 values are 1, 1, 1, 1 and next 4 values are minus 1, minus 1, minus 1, minus 1 for n is equal to 0, 1 up to 7. So in both these parts, part A and part B, here we have the 3 scale fast wavelet transform filter bank, and the input is having the n value, that is 0 to 7, that means the 8 values we can assign. In the first part we have the use of Haar scaling function, whereas into the part B we have the use of Haar wavelet function. So as described, this is denoted by phi of n and the wavelet transform function is denoted by psi of n here. So let us read the part C here, then we shall answer one by one. Part C is given what input sequence produces the transform. Here we have the transform value 0, 0, 0, 0, 0, 0, capital B 0 with non-zero coefficient W suffix psi of 2, 2 is equal to capital B. So here the question mark is mentioned here. So this is the part C where we are required to find the input sequence if the transform value is known to us, and within the coefficients of the transform values, one of the coefficient value at the 7th position, if you start at 1, so it is capital B here, and the relation, the condition for this particular one is given that W suffix psi of 2, 2 is actually the B here. So let us start to answer the problem for the part A here. As we have the given data, we can write that the input phi of n, that is the scaling function of the Haar wavelet, is represented with the 8 values. All the values are positive 1. So 1, 1, 1, 1, 1, 1, 1, 1 here. So this forms a set here. So we can write here phi suffix 0, 0 of n here for a 3 scale fast wavelet transform filter bank. We have to provide this particular input. So with the Haar scaling and further the Haar wavelet functions. Since the wavelet transform coefficients measure the similarity of the input to the basis functions, the resulting transform we can write here. The set can be W suffix phi of 0, 0, W suffix psi of 0, 0, W suffix psi of 1 comma 0 w suffix psi of 1 comma 1, w suffix psi of 2 comma 0, w suffix psi of 2 comma 1, w suffix psi of 2 comma 2, and lastly w suffix psi of 2 comma 3. So these values we have in this particular set, that is 2 under root 2, and rest of the values here we have 0. So 0 0 0 0 0 0 and last value is also 0 here. The w suffix psi of 0 comma 0 term can be computed with the condition that is j0 is equal to k is equal to 0. Now the answer B can be given. So for B we are going to use the same reasoning as we have done in the part A, the same procedure we are going to see. So the transform value we can obtain with 0, 2 under root 2, and rest of the values are 0. In the part A, only the first coefficient was having the non-zero value, rest of all the coefficient values were equal to 0. Here the second value is non-zero and others are zeros. So here the set is formed by 0, 2 under root 2, 0 0 0 0 0 0. So this completes the answer for part A and part B, which were actually the similar procedures, with the only change that the first one was provided with the Haar scaling function. The all coefficient values of the input were positive 1, and in the part B the input was of the Haar wavelet function. The first 4 coefficients were positive and the last 4 coefficients were negative 1 here. Now let us answer part C. So answer for part C, for the given transform we can have the relation given into the problem statement, that is w suffix psi of 2 comma 2 is equal to capital B. So capital B is a part of the set of the transform, that is given value, and for all other transform coefficients here we have 0. So thus the input must be proportional to psi of 2 comma 2 for x here. The input sequence must be of the form, that is 0 0 0 0 C minus C 0 0. So C is assumed here, and for determination of C here we can have the use of the equation, that is w suffix psi of j comma k can be computed as 1 upon under root m, the summation for the factor x here over the f of x, the input, along with the function, that is psi suffix j comma k over the variable x here. So here we can write w suffix psi for 2 comma 2 is equal to 1 upon under root 8. Total 8 samples we can say here. Inside the bracket here we have the product of f of 0 with psi suffix 2 comma 2 of 0. The second term will be a product of f of 1 with psi suffix 2 comma 2 of 1 here. The third term will have the multiplication of f of 2 with psi suffix 2 comma 2 of 2 here. Next we have the product, that is f of 3 with psi suffix 2 comma 2 of 3 here. The next value we have the multiplication obtained by f of 4 with psi suffix 2 comma 2 of 4 here. The next 3 terms we can have the multiplications of f5 with psi suffix 2 comma 2 for 5, f of 6 with psi suffix 2 comma 2 for 6, and lastly here we have f of 7 with psi suffix 2 comma 2 for 7. So we can substitute the values here. The next step we obtain onto the right hand side. Here initially we have 1 upon under root 8, and inside these curly brackets we can have 0 into 0 0 into 0 0 into 0 0 into 0 the 4 times. The fifth one shall be c into multiplication of 2 factor. Next we have minus c into minus 2, the resultant will be definitely the same, and these 2 terms at the last are also 0 into 0. So now finally we can write 1 upon under root 8 in bracket twice c plus twice c. So we can make it 4c upon under root 8, and simply we can write under root 2 times c here. Because this coefficient is known to have the value capital B as given statement, we can have under root 2c is equal to capital B, or c is equal to under root 2 by 2 times capital B here. Thus the input sequence we can write 0 0 0 0 under root twice b divided by 2 minus under root twice b divided by 2 0 0. So this was the answer to the part C. To check the result, we have to substitute these values into the equation given by w suffix psi for j comma k obtained as 1 upon under root m summation factor x over f of x, the input, and psi suffix j comma k of x here. So therefore we can have w suffix psi of 2 comma 2 computed as 1 upon under root 8. Here we have 0 into 0 for the 4 terms. The next it will be under root 2 by 2 of b into 2. Next we have minus under root 2 by 2 into b into minus 2, and these two terms are the multiplications of zeros. So the simplification to the next step, we obtain 1 upon under root 8. In the bracket we have only the two terms at fifth and sixth position, that is under root twice b plus under root twice b. So simply we compute it to the capital B only. So the condition is satisfied and our answer is correct. So I hope the answers to part A, part B and part C have got cleared your concepts regarding the use of wavelet transform. So by the next lecture we shall be having the start of the video with the title redundancy in the images, that is actually a part of image compression. So image compression is one of the fundamental steps in the digital image processing. That will be the chapter number 9 we are going to start with. So if you like the videos regarding the theory, practical sessions using the MATLAB and the miscellaneous problems for the practice purpose, for more information you can subscribe to Ekeeda channel. Thank you.